Hello, this is Mrs. Bennett, and today we are going to be talking about solving compound inequalities, specifically the and type or the intersection type. In class we've already graphed these. We've already solved them if they were written, for example, like this. So this is an and type compound inequality. For these, you would just solve each one and get what x was equal to on each of these, and then you would graph your number line. So there is another type of and compound inequality that still means intersection, but it looks different, and that is this type. So let's do -5 is less than 2x plus 3, which is less than or equal to 11. This is an and type inequality. Now there are a couple methods for doing this. My favorite is to look at this as 3 different sections. So we have a section on the left, a section in the middle, and a section on the right. So you can solve these just like any other inequality by working from the variable. So our variable term is here in the middle. It says 2x plus 3. We would like to solve for x alone. So we need to get rid of plus 3 by subtracting 3. Now, in a normal inequality, you would just have a left side and a right side. But this time we have 3 sides. So instead of just doing left and right, we're also going to do all 3 sides. Okay, so that will give us -8 is less than 2x, which is less than or equal to +8. Now we need to undo this multiply by 2, and we will do that by dividing by 2, and we are going to get all 3 sides. -8 divided by 2 is -4. The middle is x, and the right side is 4. Now here is where you have to remember if you need to flip the sign or not. And we're dividing by a positive, so the relationship still says less than and less than or equal to. And now we are ready to graph. So we put in our potential boundaries. And this is an and, so we pick numbers from each section. So if I pick a number from over here, -10, is -4 less than -10, and is -10 less than or equal to 4, and that is a no. So this guy would remain blank. Let's pick a number from in here. 0. Is -4 less than 0? Yes. And is 0 less than or equal to 4? Yes. So our middle section here is shaded. And then we'll check a number from over here. Let's do 10. Is -4 less than 10? Yes. And is 10 less than or equal to +4? And that is a no. So this will remain blank. So now that we know what section our solution set is in, we will now do our circles. So the boundary right here at -4 is an open boundary because it's not equal. And then our boundary here at +4 is closed because it is equal. And that is how you solve and inequalities, where it looks like all one inequality.